Hey, G67 12.2A3 compound probability worksheet and little tutorial here. Well, I don't know. Let's take the first one. What the heck? You roll a single die numbered from 1 to 6. You know me, I like to sketch. What is the probability of rolling a 6 the first time and an odd number the second time? Well, it's a normal die, so there's a 1 in 6 chance of rolling a 6 the first time. But odd numbers, it could be a 3, a 5, or a 1. So there's really a 3/6 chance or a 1/2 chance of getting an odd number. So we can just multiply those guys straight across and got 112. So that's an independent event. Doesn't matter what you roll on the first. It's not going to impact the second one. Now let's go over to the old marble jar here. Well, candy jar. A jar contains 12 caramels, 7 mints, and 16 dark chocolates. Well, that was a mistake. Who likes dark chocolate? What is the probability of selecting a dark chocolate and then a caramel, or caramel, as my friends would say? Well, let's add these up. 12 and 16, what's that going to be? 28 and 7. Looks like there's a total of 35. And it's not going to be replaced. It's going to be eaten, of course. So what's the probability of selecting a dark chocolate? Well, the dark chocolate is going to be 16 out of 35. Okay, and then a caramel. Well, there's only going to be 34 pieces because I'm going to eat the dark chocolate. However, there's probably still 12 caramels left. So these are some pretty ugly numbers here. And again, you can use a calculator on this target, but I'm just going to go ahead and just do some little bit of reducing here. The first thing I'm going to do is I'm going to divide by 2 here and get this down to 6/17. Then got to check. I think that's all I can do. So I've got 16/35. That's going to be times 6/17. So I'll grab the old calculator here. 16 times 6 is 96. So this will be 96. And then on the bottom, we've got 35 times 17. 35 times 17. That's 595. And then we got to see if that can be reduced. Now, in theory, if I've done everything I can reduce top and bottom, back and forth, we shouldn't have to reduce. But let's just think about it. Think about the factors of 96 and if they would go in. Well, we know that 1 goes in, but obviously that doesn't really help us. 2 is not going to go in. 3 goes into 96. 4 goes into 96. 4 is not going to go in. 3 is not going to go in here because 5 plus 9, 5 plus 5 plus 9 is 19. 3 isn't going to go into 19, so 3 is not going to go into 595. 4 is not going to go in because it's an even number. 5 doesn't go into 96. 6 does go into 96, as you know, 16 times. But 16 is an even number. That's not going to go in there. And so you could work your way all the way through that if you'd like. And thinking about those factors, 8 goes in, but it's even. 12 goes in, it's even. Not too many odd numbers that go into 96 other than 3 and 1. And so on. You'll find that all the factors are going to be odd. Sorry, all the factors of 96 are going to be even except for a 1 and 3. So this dude is in simplest form. I just know that if I do everything I can do to reduce crosswise and up and down on both fractions, I'm already there. So we have 96 595th chances of getting that. Kind of a weird answer, but it is what it is. Thanks, bye.